Good morning. This is Dr. Turner for Integrated Math 2. Today we're going to be covering 4.6, which is solving quadratics using the quadratic formula. We've talked about a lot of techniques in Unit 4 and leading up through Unit 3 of different ways we can solve quadratic functions. We've looked at graphing, we've looked at factoring, grouping, completing the square, taking the square root, special cases, all different kinds of things. Now we come to the quadratic formula. The nice thing about the quadratic formula is that it's going to work regardless of the problem. So we talked about different techniques of when you might want to factor versus completing the square versus special case formula, all those types of things. Quadratic formula will work anytime for any quadratic equation. And that's including if we have two solutions, one solution, or no solutions. It's not necessarily the easiest method, but it is a method that you can use regardless. Okay? And it is essentially just a bunch of arithmetic. So hopefully it's not too bad today, but we'll go ahead and get started here. So quadratic formula, first off, what is it? Well, quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And the a, b, and c here are referring to the quadratic equation in standard form, ax squared plus bx plus c. So whatever those coefficients are, a, b, and c, the constant, we're going to take those, we're going to plug them in for a, b, and c into this formula, keeping in mind our signs, being careful with which is a, and b, and c, and then evaluate. So let's look at an easy example to start. X squared plus 10x plus 21 equals 0. So you want to identify your a, b, and c. If you're doing this in the integrated math textbook, if you're looking at the supplemental resources, sometimes that's all they want you to do. Just what's a, what's b, what's c. And so you're getting to the practice of identifying before you actually solve. But here, remember, if there's x squared by itself, that means it's just 1x squared. So a is 1, b is 10, and c is 21. So once I have those identified, I'm going to plug them into the formula. I have x equals negative 10 plus or minus the square root of 10 squared minus 4 times a is 1 times c, which is 21, and that's all over 2a. As you're going through, obviously for my class I let you guys use notes. If you're not allowed to use notes and you're trying to figure out a way to remember the formula, because that's kind of the expectation, some teachers will teach the mnemonic devices or put it to the tune of a song, most common being Pop Goes the Weasel. So it's x equals negative b plus or minus square root of b squared minus 4ac all over 2a. And so if that helps you remember it, good. If not, it's there. But now we've plugged in my a, b, and c, and we're just going to go and do the arithmetic now, remembering our order of operations. So first, I'm going to simplify what's inside the radical. So I have 10 squared, which is 100. And then I have 4 times 21, which is 84. And this is all over 2 times 1. I'll do 100 minus 84 inside the radical. And that gives me square root of 16 all over 2. From here, we're going to take the square root of 16, which is 4. Remember that you always have two answers to a square root problem, but we already have the plus or minus there, so we don't need to write it twice. Okay? And then that's all over 2. From here, because you want to write your answers separately if you have two answers, from here you could either divide both by 2 first and then combine, or you could combine and then divide. So either one's going to get you to the right answer. Let's say I divide first. My first answer then would be negative 5 plus 2, which is negative 3. And my second answer would be negative 5 minus 2, which is negative 7. Remember, for the most part, you're going to have two answers on each of these. It looks like a lot, but once you do it a few times, it kind of starts to sink in. So let's keep chugging along here. X squared minus, let's say, 12x plus 27 equals 0. So, using my formula, a is 1, and you can highlight if you want, if that helps. But c is 27, because I had that color up already. My b is negative 12. You always have to take the signs with you. And then my a in this example here is still 1. So I'll plug those into the quadratic formula. I have x equals negative b. Again, you got to be careful with signs. So it's negative b. My b is already negative. So those two negatives will become a positive here in my next step. Plus or minus the square root of b squared minus 4ac. And that's all over 2a. So the two negatives become a positive. I have 12 plus or minus square root. 12 squared is 144. 4 times 27 is 108. And it's all over 2. Now I have 12 plus or minus, that's 36, all over 2. Square root of 36 is 6. Again, from here you could divide or split it. Because we divided first in the first example, let's say we split it in the second example. This would be 12 plus 6 over 2 and 12 minus 6 over 2. Simplify with the arithmetic, so 12 plus 6 is 18, divided by 2 is 9. 12 minus 6 is 6, divided by 2 is 3. Now, for these two examples here, again, it's up to you how you want to decide to solve these. When I have an x squared that's a 1x squared, or a leading coefficient of 1, typically I'm going to factor, right? Do the magic x, what numbers multiply to get 27 but add up to negative 12? Right? And you can write it in factored form, 9 and 3. Same thing with the first example, the numbers that multiply to get 10, or multiply to get 21, excuse me, but add up to 10, 7 and 3. So my answers were negative 3, negative 7, right? However, if I have something that's not a 1 for my leading coefficient, that's usually when I'm going to use the quadratic formula. It doesn't mean they're not factorable, but it takes a little bit of extra work. So up to you how you want to do that. Let's look at a couple examples here where I do have a leading coefficient, something other than 1. For instance, let's do, we'll do 2x squared plus 11x plus 12. And I'm asked to solve using quadratic formula. It's possible that I could factor this. I don't know. So that's one advantage to using quadratic formula again, is that it will always work. So a is 2, b is 11, c is 12. This is x equals negative b plus or minus the square root of b squared minus 4 times a times c, and that's all over 2a. We're going to go through and clean this up. So negative 11 plus or minus the square root. 11 squared is 121. 4 times 2 is 8. 8 times 12 is 96. And that's all over 4. Okay, so x equals negative 11 plus or minus 121 minus 96 gives me 25. That's over 4. Square root of 25 is 5. So again, you can divide first or split first. Because 11 and 5 don't divide evenly with 4, I would combine. So negative 11 plus 5 over 4, and negative 11 minus 5 over 4. On the left, negative 11 plus 5. That's going to give me negative 6 over 4. For me, I don't care if you want to do decimal, you can, or fraction, whichever is easier. But negative 6 over 4, I'm going to leave it as a fraction, and I'm going to simplify it to negative 3/2. And on the right, negative 11 minus 5 is negative 16 over 4 equals negative 4. One thing I want to address here, again, I'm trying to give you guys simplified answers, or simpler problems. When you do it on a standardized test, you don't know what kind of answers you're going to get. You might get whole numbers. You might get fractions. You might get radicals or decimals that are non-terminating. So there's all types of different quadratics that you could be given. Now, because we're focusing on the basics here in this class, I'm trying to give you answers that either are going to have whole numbers as solutions, or ones that can be simplified like we did here for number 3. When I looked at the discriminant, what's inside that radical sign, I got something that ended up being a perfect square. So even though I ended up with a fraction, it was a clean fraction, right? 3/2. It's not too bad. And I'm specifically picking these numbers, as a teacher, going backwards so that I am making sure that you have what I want you to get as an answer, either a whole number, if that's what we're looking at, or a simple fraction, if that's what we're looking at. It doesn't mean that you're going to get that every time. Now, for your assignment, yes, they're going to look like, at worst, something like number 3. I do want to show you, though, that sometimes it's going to be something kind of ugly. So on these other examples, I'm picking questions that I know have actual answers. So number 4, let's say, just throwing out random numbers here. I'm going to do 5x squared plus 15x plus 4. So I go in and I plug in my a, b, and c. X equals negative b plus or minus the square root of b squared minus 4 times a times c, and that's all over 2a. So we're going to follow the same steps as before. We're going to start out with simplifying what's inside the radical. So 15 squared, that's going to give me 225. And then 4 times 5 times 4 gives me 80. And that's all over 2 times 5. From here, 225 minus 80. All over 10. Square root of 145, so this is what I was talking about, is not a perfect square. So depending on the class, you might be asked to, approximate as a decimal up to a certain number of significant digits, or you could be asked, what's more commonly, to write it by simplifying the radical, which is what I would have you do in this class. So there is a Unit 0 assignment that covers that, if you are interested. When we are looking at square root of 145, I know that 9 goes into, sorry, not 9. I'm looking for what numbers can go into 145 that are perfect squares, if any. And so I'd be looking at problems, does 1 go into 145? Yes. And then go up. Does 2? Does 4? Does 9? Does 16? Does 25? So on and so forth, until I see if any of those go in. If you can simplify it, you need to. If you can simplify it, you need to do that. That's a requirement. Okay. But looking here, going through my perfect squares, 1, 4, 9, 16, 25, etc., 145 doesn't have any perfect squares that go into it. 145 is what we call a product of primes. 29, like let's say you're trying to do a factoring tree, you know that 5 goes into 145, so that's 29 times 5. But 29 itself is a prime number. So in this case, I would be left with negative 15 plus or minus the square root of 145 over 10. I can't simplify that radical anymore. So we can still write our answer separately. Negative 15 divided by 10 is negative 3/2. And you would have plus, and you just got to leave it like that. 1 square root of 145 over 10. And then your other answer is negative 3/2 minus square root of 145 over 10. Now for me, if you get here and it's clear that you can't simplify it any further, you can just leave it there. You don't have to write it as two answers, but most textbooks and most teachers are going to ask you to write it out as two answers separately. So just pay attention to the instructions, what you're being asked to do. All right, guys, that's it for today's lesson. I know there's only a few examples here, but there will be more under supplemental resources. And if you have questions, please attend office hours. Have a good day, and I will talk to you soon.